Good morning, students. Welcome to online physics class. Today, I am going to explain about the photon, characteristics of photon, next de Broglie hypothesis along with de Broglie wavelength. First, here we are going to discuss about the photon. What is meant by photon? Photon is nothing but a pocket of light energy, or else we can say that one radiation consists of pockets of energy. Those pockets of energy are nothing but photons. Then what are the characteristics of photon? The first point is that photons travel with the speed of the light c. Here whatever the photon is there, that is nothing but a pocket of light energy only, means that is present in the light only. With what speed the light is traveling, with that speed only the photon travels. So that photons travel with the speed of the light, that is c. Second point, rest mass of the photon is zero. What is meant by rest mass? Rest mass is nothing but it is the mass of the particle when it is at the rest state. Means that photon exists at the rest state with the zero mass. No, it doesn't mean that. There is no chance of existence of the photon in the rest state. Then how it is possible? Here I am going to explain that point. From the Einstein theory of relativity, we can use the equation, that is m is equals to m naught divided by square root of 1 minus v square divided by c square. What it indicates? This equation helps to determine the mass of a particle when it travels nearly speed of the light. M is the mass of the particle when it is moving with nearly speed of the light. M naught is the rest mass of the particle. V is the velocity of the particle. C is the speed of the light. From this one, what we have to determine? Rest mass. So that take this denominator term LHS. What it will be? M into square root of 1 minus v square divided by c square. M naught is equals to what? M into square root of 1 minus v square by c square. Now the velocity of the photon, that is equals to what? Speed of the light. So that velocity of the photon is equals to speed of the light. Now here we are going to substitute in place of v, that is c. Here substitute v is equals to c. We got, that is m into square root of 1 minus c square divided by c square. C square gets cancelled and the remaining thing is what? 1. Here you can observe, in the numerator we have the c square, in the denominator also we have the c square term, so that they gets cancelled. We got 1 minus 1. What is the value? 1 minus 1 is equals to what? 0. 0 into m is equals to what? 0 only. So that m naught is equals to 0. M naught is what? Rest mass of the particle. Which particle we have taken here? That is nothing but a photon. Rest mass of the photon is equals to 0. What does it mean? Photon cannot exist at the rest state. Next point is that energy of each photon is given by E is equals to h nu, where h is what? Planck's constant, and nu is what? Frequency of the photon. Whatever the frequency value is there, if you substitute and if you multiply with the h value, that is Planck's constant value, you will get the energy of the photon. The energy of photon can be determined by using the equation E is equals to h nu. H is what here? Planck's constant. Means that if you observe the equation, you will come to know that the relation between energy and the frequency of the photon. Here, if the frequency of the photon increases, energy value also increases. If the frequency of the photon increases, energy value increases. If the frequency of the photon decreases, energy value decreases. Means that here energy of photon is directly proportional to the frequency of the photon. Energy is directly proportional to the frequency of the photon. When a value is increasing, then another value also increases, then we will say that one that is directly proportional. If frequency value increasing, then energy value increases. If a frequency value decreases, energy value decreases. What is the relation between them? That is nothing but directly proportional. Energy of the photon is directly proportional to the frequency of the photon. Next, fifth point, photons are electrically neutral. Whether they carry any positive charge or negative charge, no, they don't carry any charge. If they don't carry any charge, then we have to say them they are electrically neutral. Next, sixth point, that is momentum of the photon. Momentum of the photon is given by P is equals to h by lambda. P is what? Momentum. H is what? Planck's constant. Lambda is what? Wavelength. Then how we got this equation? Here I am going to explain that one. Here you can observe the Einstein mass energy relation. I think you are familiar with this equation, Einstein mass energy relation, that is E is equals to what? mc square. E is equals to what? mc square. M is what? Mass. C is what? Speed of the light. E is what? Energy. This is the relation between that is energy and mass. Now mc square can be written as mc into c, that is c square is written as c into c. Now m is what? Mass. C is what? Speed. That is the speed of the light. That can be written as P is equals to, that is momentum, P is equals to mv. So that here in place of v we can write a c. So that P is equals to what? mc. In place of mc, what we have substituted here? P. The remaining thing is what? P into c. Energy is equals to P into c. Energy is equals to what we got here? Energy is equals to P into c. Energy is equals to P into c we got. Then here energy, and energy of the photon is given by what? Energy of the photon is given by E is equals to h nu. In LHS, in place of energy, what we have substituted? H nu. H is what? Planck's constant. Nu is what? Frequency of the photon. P is what? Momentum. C is what? Speed of the light. Now here we got h nu is equals to P into C. Now here C, whatever the RHS C is there, take that one to the LHS term, then what it will be? H nu divided by C is equals to what? P. Now we know the basic relation, that is nu is equals to what? Nu is equals to what? C by lambda. Nu is equals to C by lambda means, nu is equals to C by lambda means, just take this C LHS, what it will be? That is nu by C is equals to 1 by lambda. What we have observed here, nu by C is equals to 1 by lambda. If nu by C is equals to 1 by lambda, substitute here h nu by c is there. In place of nu by c, what you can substitute? 1 by lambda, that is h into 1 by lambda is equals to p. P is equals to what we got? That is h by lambda. P is equals to what? H by lambda. This point only I have explained here. That is P is equals to momentum of the photon is given by h by lambda. H is what? Planck's constant. Lambda is what? Wavelength. Here momentum of the photon is given in terms of the wavelength, that is P is equals to h by lambda, or else we can use a general equation also. P is equals to mc. M is the mass of the photon, c is the speed of the light. Why you have taken here c? Why? Because photon is traveling with the speed of the light. These are the characteristics of the photon. The next topic is de Broglie hypothesis. What is meant by hypothesis? Hypothesis is nothing but it is a suggestion or an idea given without conducting an experiment. Means that without any experimental observation, if you make any suggestion or idea, we can say that one as the hypothesis. Here we are going to discuss about the de Broglie hypothesis. Next, de Broglie made a bold and novel suggestion. What he made? Like radiation, matter also has dual nature. Then radiation has the dual nature. We know that one radiation has the wave nature. In all the previous classes, we have observed that when light falls on the material, the free electron absorbs the energy and it comes out of the metal surface. Those are nothing but a photoelectron. According to Einstein, photon is associated with the definite value of the energy and momentum. In the previous topic, that is characteristics of photon, I have explained about the energy of the photon, that is given by E is equals to h nu, and momentum of the photon, that is P is equals to what, mc, or else we can take that one as a h by lambda. This is possible when the particle or else when the photon is in the motion state only. This is the property of a particle when it is in the motion state. Whatever this property is there, that is having the definite value of the energy and momentum, this is the property of a particle in motion state. Hence, the light is considered to be have particle nature. The light is having wave nature as well as a particle nature. Then we are saying that one radiation has two nature, that is a particle nature as well as a wave nature. In the same way, matter also has the dual nature. According to de Broglie, matter, that is nothing but like electron. Matter is nothing but it is something which occupies certain space and which is having certain mass. Then we can say that one as the matter, whether it may be electron, whether it may be proton, whether it may be table, whatever it may be, anything can be said to be matter when it has a certain mass and if it occupies certain space. Now, matter in motion, that is nothing but like electron, in motion exhibits wave properties. What they exhibit? Wave properties under suitable conditions. What are those suitable conditions? Nature manifests in two fundamental forms. They are nothing but matter and energy. That is nothing but if energy is there, that is possible due to matter, and if matter is there, we can get that one in terms of the energy. Means that matter and energy both are interconvertible things. If radiant energy shows dual nature, then out of symmetry consideration, matter in motion should also exhibit the dual nature. This is about the de Broglie hypothesis. Next, what is matter wave? These are the waves associated with the moving material particles. Means that when a particle moves with a certain velocity, whatever the wave is associated with that one is there, that wave is called as the matter wave. That matter wave is also called as the de Broglie waves. These matter waves are proposed by the de Broglie. Hence, these waves also called as the de Broglie waves. Next, de Broglie wavelength. Wavelength associated with the moving material particle. When a particle moves with certain velocity, whatever the wavelength is there, wavelength of the wave is there, that wavelength is called as the de Broglie wavelength. That is expression for de Broglie wavelength of a particle. De Broglie wavelength of a particle is given by lambda is equals to h by p. H is what? Planck's constant. P is what? Momentum. Here, in place of momentum, what you can write? P is equals to, sir, momentum of the particle is given by P is equals to m into v. M into v. M is mass, v is velocity. Here, lambda is equals to h by p. Lambda is equals to h by p. H is Planck's constant. P is momentum. Momentum can be written as the product of mass and velocity. So that in place of momentum, I have written m into v. Now, lambda is equals to h by p, or else we can write h divided by m into v. Lambda is what? De Broglie wavelength. M is what? Mass of the particle. H is what? Planck's constant. V is what? Velocity of the particle. This is the expression for the de Broglie wavelength of the particle. Next one, that is expression for de Broglie wavelength of a photon. Again, we will use the above equation only, but in place of particle, what we got here? Photon. H is Planck's constant, m is mass of the photon. Then c is what? C is the speed of the photon. Here, why we didn't take V here? Why? Because the photon is traveling with the speed of the light, so that we have written h divided by mc. H is Planck's constant, V is velocity of the photon, m is mass of the photon, lambda is de Broglie wavelength. This is about the de Broglie wavelength of a particle and de Broglie wavelength of a photon. De Broglie wavelength of a particle is given by lambda is equals to h by p, or else lambda is equals to h divided by mv. Here de Broglie wavelength of the photon is given by lambda is equals to h divided by m into c. H is Planck's constant, m is mass of the photon, c is speed of the photon. That is expression for de Broglie wavelength in terms of kinetic energy of the particle. Now we have to write the de Broglie wavelength, whatever lambda is equals to h by p is there. Lambda is equals to what? H divided by p is there. We have to express this one in terms of the kinetic energy. Note point here you can observe at the right side. Note, that is, we know that kinetic energy is equals to what? P square by 2m. Ke is the kinetic energy. We can take that one as the E subscript K, that is kinetic energy. That is P square by 2m. P is what? Momentum. M is what? Mass. Here, what we have to get? P, momentum we have to get. So that here, take this 2m which is present in the denominator to the LHS. If you take that one to the LHS, what it will be? 2m into Ek. Ek is what? Kinetic energy. Here we have taken Ke. Make that one as the Ek. Both are indicating the same thing only. 2 into mass of the particle into kinetic energy of the particle is equals to P square. What we have to get? P. If you take this square LHS, what it will be? Square root. Square root of 2m into Ek is equals to P. P is what? Momentum. Then m is what? Mass of the particle. Ek is what? Kinetic energy of the particle. Now in place of P, we know the basic equation for the de Broglie wavelength. What is that one? Lambda is equals to h by p. In place of P, we can write square root of, you can observe the equation here. Lambda is equals to what? H by p. In place of P, what we have written? That is square root of 2m Ek. This is the de Broglie wavelength expression in terms of the kinetic energy. That is lambda is equals to h divided by square root of 2m Ek. M is mass of the particle, Ek is kinetic energy of the particle, lambda is the de Broglie wavelength, h is what? Planck's constant. This is about the expression for the de Broglie wavelength in terms of kinetic energy of the particle. Next expression, that is expression for de Broglie wavelength in terms of accelerating potential. Again, we know the basic equation. Lambda is equals to what? H divided by P. Now, in place of P, we have to write the expression which is involving in terms of the accelerating potential. Now we know the basic definition for the potential, that is work done divided by charge. Now in place of work done, we have to make that one as the kinetic energy divided by charge. Now from this one, kinetic energy is equals to what? V into Q. If you take this Q LHS, what it will be? V into Q. V into Q is equals to kinetic energy. Now whatever the equation is there in the previous one, that is lambda is equals to h divided by 2m Ek. Square root of 2m Ek. Now in place of Ek, what we got? V into Q. Now substitute that one, h divided by square root of 2 into m into QV. In place of kinetic energy, we have written that Q into V. Now in the previous one, whatever the de Broglie wavelength in terms of kinetic energy is there, here it is there. That one is expressed in terms of the accelerating potential, since kinetic energy is equals to potential into charge. So that here in place of Ek, we have written Q into V. Now where m is what? Mass of the charged particle. M is what? Mass of the charged particle. Q is what? Magnitude of the charge. V is what? Accelerating potential. H is what? Planck's constant. This is about the de Broglie wavelength in terms of the accelerating potential. that is expression for de Broglie wavelength in terms of accelerating potential of an electron. In the previous one we have taken particle, but here we have to take for an electron. De Broglie wavelength, that is lambda is equals to h divided by square root of 2m into qv we got in the previous term. Then here charge on the electron is equals to what? That is indicated by E. So that in place of q, whatever the previous expression is there, here it is there, lambda is equals to h divided by square root of 2m qv, h divided by square root of 2m qv. In place of q we have to substitute the E. Q is equals to E. Now the de Broglie wavelength in terms of the accelerating potential for an electron is given by lambda is equals to h divided by square root of 2m ev. M is mass of the electron, E is charge on the electron, V is accelerating potential, H is a Planck's constant. This is about the de Broglie wavelength. De Broglie waves are matter waves, and de Broglie wavelength in terms of kinetic energy and accelerating potential for a particle and accelerating potential for an electron. In the next class I am going to discuss about the Davison-Germer experiment. Thank you.